All right, we're going to dive a little deeper into absolute value functions and their key attributes. We're going to continue to talk about domain restrictions. For instance, here in part A, we have g of x is equal to the absolute value of x minus 3, and we're restricted from x being equal to 0 all the way up to x being equal to 4. Now, that includes all the values in between. So if I were going to fill in my table here, I would start off with 0, 1, 2, 3, and then 4. I don't need the bottom portion of this table. That would mean that our lowest value is going to be 0. Whoops. And the highest value would be 4. So there is our domain restriction. It's got to match, right? Whatever was up here at the top. So what would that look like for our range? Well, let's go to Desmos for that. Let Desmos calculate some of this. Whoops, wrong direction. Desmos is right next to it. We're going to type in, I think it said G, didn't it? Let's go double check. Yeah, let's use the G. I wonder if it'll recognize it. G sub 1 of x is equal to, go back and peek the absolute value of x minus 3. So let's grab the absolute value down here. X right arrow space bar minus 3. There it's shifted. Now we're going to open the table of values. And we said our restriction is from 0 to 4. So I'm going to type in 0, 1, 2, 3, and 4 before I forget. Now notice nothing popped up. It's because we got to fix the top of this table here. It's got to look just like the equation. So g sub 1 of x. Get rid of the box. It doesn't like that gray box. And there's our values. Negative 3, negative 2, negative 1, 0, 1. So update that. Negative 3, negative 2, negative 1, 0, negative 1. Did I type that correctly? Yeah, there we go. Negative 3, negative 2, negative 1, 0. It's positive 1. That's the one I messed up. Okay, so if we look for the lowest value in this case is negative 3. So that's going to be for our range. And then the highest value, what's the biggest y value here? It looks like it's positive 1. Now, I don't think that's going to give us a V shape. If we wanted to actually put in restrictions here, I would just hit the space bar at the end of my equation. I'm going to use what's called the curly brackets. That's the set notation. And we said we wanted to go from 0 less than x is less than, and we wanted to go all the way up to 4. So notice now that's saying some of these values are undefined. That's because I forgot to put lines under here. We actually want to include, don't know what I did there. I'm going to have to go use their arrows. I can't use my keyboard ones because we need the line underneath it, right? We need to be less than and equal to, and now it's no longer undefined. There's our values. And look, it only graphs the portion of the line now between 0 and 4, so we don't see the whole V, just the portion of the V that pertains to this problem. So now maybe it's easier to see the domain goes from 0 only up to 4, and then the range down here at negative 3 all the way up to positive 1. So that's why this is negative 3 to positive 1. Right in the same thing, I'm going to do a little copy and paste here. I'm going to do this in set notation. We're going to get rid of the brackets now. I don't know if this was faster to copy and paste or not. Didn't get rid of the brackets anyway. So the range is y. I'm going to put a y in between, and then this one's going to get an x. And we need arrows going to the left. So I'm going to hit Control underline to get the arrow there, and then I'm going to type right here, same thing. There's that one. Nope, it didn't underline it. Control U is the underline. There we go. Still didn't get rid of the bracket. What's going on here? Control U. There's our line. Control U, and now we've done it. This is interval notation, set notation. I can copy and paste a picture of my graph in here as well. But now we've answered some of the key attributes. Now, when you have domain restrictions, a lot of times you're going to talk about what's called the min and max. It's the lowest and highest point within the region that you're looking at on the graph. We are looking at just this part of the line. So it's kind of like the range when you go lowest to highest. The idea is when x is 0, y is equal to -3. That's the minimum. That's the lowest point in the graph, the smallest value. When x is equal to 4, the max value is +1. So our minimum is -3, and our maximum, our highest point, is 1. So the min is y equals -3, x equals 0, and the highest point is 1 at x is equal to 4. We've got some other stuff that we're trying to look for in here. What if they said determine g of -1? What they're telling us is the input is -1. So what would the output be? It's as simple as saying g sub 1 of -1 is undefined. Why is that? Let's pull the graph up, because here's where x is equal to -1. Maybe pull my pen up. Well, is it going to let me read? -1 is right here, and if you look down at the graph, got some pop-ups here. Go down. The line doesn't make it there. It stops right here at 0. So it's undefined because there's no portion of the line that we're including. Now, if we did the whole thing, we didn't have restrictions, maybe there would be and we'd have a value. But right now, it's undefined. It does not exist at that location. So going back over here, if that happens, you can write DNE, or you can write, that means it does not exist, or you can write undefined at that point. What about a 2? Is it defined at 2? Let's go take a look. Oops, it's over here. At x equals 2, that's this portion right here. We go down, and yes, it's there. There's part of the line. What is the value at that point? When x is equal to 2, the output's -1. So if I type that g sub 1 of, whoops, that's f. Yeah, we'll just type it in here. What was the value? 2. So we'll change the -1 to 2 this time. And look at that. Yep, it is defined. It's -1, just like the graph said. So for this one, we will type -1. What's the parent function? The parent function is always g of x or f of x is equal to the absolute value of x. Those aren't straight lines. Those are leaning lines. Let's try that one. There we go. So no numbers, just the absolute value in the x. What is the x-intercept? Do we have one of those? Yeah, it does cross the x-axis. That's going to be 3, 0. Sometimes it does, sometimes it doesn't. And what is the y-intercept? Let's go peek at that. Yep, it touches the y-axis also. That is at 0, -3. So it's where the y-axis meets that line, 0, -3. If it doesn't have one of those, you'll just say none. But this time they do. They have both the x and the y-axis. Now this one was given to us with domain restrictions and interval notation. Maybe it'll happen that it's in set notation. Oh, I guess I didn't do it in set. Maybe I'll do it in the next one. This one's still in interval notation, -2 to 1. So they're telling me that my table is going to start at -2, -1, 0, 1. And that's it. That's all we can do. Let's come back over here to Desmos. This time it's x minus 2 inside the absolute value bar. So we're going to put a -2 here. Notice I didn't delete everything. I'm just kind of updating it. It's a faster way to go about it. The restrictions are -2 to +1. So we're going to type -2 all the way up to +1. And again, I'm going to pull my graph down to see it. You don't get to see the whole V shape with this little window they're making me stay within. Notice we have a couple undefines as well, 2, 3, and 4. Oh, I guess that's because we didn't update our table, did we? We started -2, -1, then go to 0, 1, and that's it. We can't do that one because 1's where it says we have to stop. Looks like I did -2 twice. Let me fix this one, -1. So -2, -1, 0, 1. Yep, we got them all. All right, so 4, 3, 2, 1. What's the lowest y value? That looks to me like it's 1, and the biggest y value here is 4, so that's going to be our range. Let's say the lowest was 1, comma, the biggest was 4. Close it with brackets. Those are included. Our domain restriction was given to us, so we just copy what they write at the top, -2, comma, 1. And now we're going to do that with set notation. So that's going to be -2. We grab the arrow, X, and then grab the arrow again, all the way up to 1. Let's see if this might make it faster. I'm going to copy that, paste it there, change the X to a Y for the range, and for this one, looks like it was 1 all the way up to 4. So you're writing the same thing just with the arrows instead of the brackets. And then let's update our table. That was 4, 3, 2, 1. Where are we going? We know what the picture looks like. We can screenshot that from Desmos. What is the minimum and the maximum? The minimum, again, is just the lowest point. The lowest point here is +1, and that is at X is equal to 1. Lowest point, the min is 1 at X is equal to 1. Let's go see where it's maximum on this interval. Looks like it's here. Now, it's not always going to match the range. Sometimes you're going to have lines that are like real wiggly, and so it could be a little bit different. But at any rate, at -2, the maximum is +4. At X equals -2. There we go. So that's the min and max, highest, lowest point. Determine h of 1, -1. They call it h, but we're going to call it g. Confuses you, go ahead and change it to h. That is +3. So you're just saying if the input, if we plugged in -1, that would give me +3. Maybe I should explain why that is the case. Since it's input output, the idea is our function is the absolute value of x minus 2. And if we plugged in -1, -1 minus 2 is -3. We all know the bars make things positive, so the absolute value of -3 is +3. So when you're saying things like f of -1, what you're saying is you're going to put -1 in place of x, which is what I did, and then you're going to solve it to see what you get for your output, for your answer. So if we did that again, but this time with, let me scroll down, -5, if we put in -5, what would we get out? Whoops, I keep going to the wrong screen. I'm just going to change that to -5. Undefined, why is it undefined? It's because at -5, it's right about here, right? No line anywhere to be found, so it's undefined. That line stopped way over here. So if we come back, we will type does not exist or undefined, works for me. Parent function, remember the parent function is always f or an h or g, whatever you want to put. F of x is equal to x. You just rewrite it with no numbers. If you want it to match letters, go ahead and call it h, call it g, whatever you want to do, but just make sure it's only got the absolute value in the x. Is there an x-intercept for this one? Is there a y-intercept for this one? There is a y-intercept. Look, it's right there. It touches the y-axis at 0, 2, but what about the x-axis? axis, I'm sorry. The line doesn't touch it, nor to be found. Maybe if we extended it past the parameters, past the restrictions, but as of now, no, it doesn't touch it. So we're going to say it's got a y-intercept of 0, 2, but for the x-intercept, there is none. There you go. That's finding the key attributes given that you have domain restrictions.